Hey there, this is Shalini Sheetal here from Shecoders, and today we are going to learn the next topic in our series of Python tutorials, and this time it is file handling. You guys must be familiar with what files are. You must have come across files of different types of extensions like documents, PowerPoints, PDFs, etc. You must have handled them directly using your operating system, right? But today we are going to learn how to handle them using the programming language of Python. You can modulate them, control them using Python directly. You don't need a graphical interface for that. You can do it directly using Python. So the module which comes in handy mostly is the OS module here. So let us import that and see what it can do for us. So the list_dir function, which belongs to the OS module, lists all the files and folders present in the current directory we are working at. So if we see here, she coders this the file outside, and if we enter file handling, there are two files present here. So if we execute this function as well, then it just lists files, which is the copy of the file I have kept as reference, and the original files we are working at. So it lists all the files which are present in the current directory. This is something which Jupyter creates by default. It is a folder, so let us ignore that. You can also use the command pwd to check out the current directory. If you want to know where you are currently at, where you are working presently at, you can just type it out pwd directly, and it will return you the location of the folder you are working in. So we are basically inside the E drive, inside the Python folder, and there is another folder named Shecoders, and file handling is the last folder we are working at, and we are working on a file present inside the file handling folder. So how do we make a folder using Python? If you would have done it using your operating system, suppose Windows, then you right click on your screen, you select the option new folder and name it as you want, and voila, a new folder is created. But suppose you want to do it using Python. How do you do that? Then using the OS module, use the function mkdir. Basically make a directory. It is the short form for that. You can remember it like that. So if we execute this command, now if we check it out, there is another folder, hello. It wasn't present before, right? We had checked it out. There were just two files present. But now if we use the same function again, you can see there is another folder named hello. There is no extension for that. So that implies that it is a folder instead of a file. So these are some of the modules named shuttle, time, and OS which will come in handy. So let us import that. Now suppose I want to know all the files which are present inside any random location. You don't have to find out in the present location only. It is not restricted to that. You can also find out the files present in any location you can want. And for that you can either provide the relative path relative to where you are currently at, or else the absolute path beginning right from the drive, specifying the folders sequentially. So I'm using the absolute relative path here instead of absolute path. And if we try to understand the meanings of this dots and slashes, it basically implies that I want to move outside of my folder once again, and I want to find out all the files present inside the Python folder here. So basically, if we execute, it gives all the files which are present here. Now suppose I want to move these files somewhere to other place. Let us move all the files which are beginning from S. Okay, let us move them inside the folder we have created here, namely this hello. Okay, so the program or the method to do that would be by using the function of OS. It is another function which is path.join. Using that, you need to mention the path you are wanting to move to. And for moving the files, actually, you need to use the shuttle module here. Move command is present inside the shuttle module, so you need to import it as we did it here. And then you need to use the move function present inside the shuttle module. So first of all, we have justified a path, the Python folder inside the E drive. And nextly, we loop through each of the files present inside the list there of that particular folder and check if it begins with S or not. Basically, we have checked if the first letter is S or not. And then we justify another path, which is namely the hello folder present inside this here, this hello folder. We have joined them using the join function, and we use the move function of shuttle. And if we execute this, we move from this path to this path, the first path in the argument to the second argument, and it takes quite some time. I guess we have encountered some error here. Yeah, since S begins from here, we can see we have the she coders folder here, so we can't move a folder to itself, right? So if we see other files must have come out, we can see these two files have already come. Let us change the file here. Let us try for F. Now I guess there won't be any problem with F. These files should be now moved inside our hello folder. Now if we check it out here, you can see all the files beginning from F have now moved inside hello folder. This is the hello folder we have created, and now if we get inside it and see, all the files beginning from F are currently in this location. So this program was executed without any error. Always remember, you can't move a folder inside it again. It will encounter an error as we did now. So if you again execute this command now, there are no files present here with F. They all moved inside of hello folder. So if you are still not clear with the join function, let us take an example. It is basically like concatenating two strings. Suppose we take first location this way, the second one this way, and we do p1 plus b2. It returns the same thing as using the join function as well. So the path module is present inside OS, and we use the join function inside that. It is basically the same thing. It joins two paths and gives you a final new path. Now, suppose you want to delete a folder now. Suppose you don't want them to be present now and you're suddenly in the mood to delete them all. Then you can use the RM tree. RM basically stands for remove. You can use that inside the shuttle module. And if you execute that, now there is no such file or directory as hello here now. We removed that. Now if we check it out inside the file handling folder, there is no hello folder here. The entire folder, including all the files inside it, were now moved to the recycle bin. Nextly, you can also check if you're encountering some error with the address or location you have provided, the relative path or the absolute path. You can use the exists function inside the OS module to check if that path actually exists or not. If it returns false, then you must have done something wrong. You must have provided somewhere, some slash or some location. You must have missed out some folder. So it won't be executing. For example, I check it out for this, then it returns true. But suppose I remove this hyphen and then execute this, then there is no such file or folder, so it returns as false. So always be careful with these paths, either relative or absolute. You can use any of them considering the situation you are in, but always remember to provide the accurate one, or it might cause problems for you and you won't be able to track them out later. So nextly, we can actually check whether the address or path, if you are stuck at some point, confused whether to use absolute, relative, what are you exactly writing, you can see if the path provided is absolute or not. You can only see dots and slashes here, right? So clearly this can't be an absolute path. Using the isAbs function, basically is absolute or not, you can check whether a path is absolute or not. Nextly, you see it begins with C drive and then goes inside it. So naturally, it is an absolute path and it will return you as true. Now you can uh, directly write inside a file as well using Python. For example, you just have to use two modulo signs and write file and the name you want. Even if the file is not present, you can create an entirely new file. And suppose you execute this, it returned you that it is writing inside that file. It is by default returned by Python, indicating that you have another file created and you are going to write inside that. And now whatever you write it here inside here will be reflected inside the file named one. If you check here, another file is created here, and if you want to see what is inside that and compare both these contents, you can clearly see whatever you have written after that is reflected here as well. So you have created another file and written inside it. Now let us get more deeper and understand these mkdir and move and all these checking out functions, all the functions basically present inside the OS and shuttle module. So let us begin by creating a folder named check. First of all, we have created a folder here, namely check. I have moved that line inside it to accommodate it inside a single function. And we take another list, namely 1, 2, 3, 4, 5, 6, 7, 8. You will see why I have named them like that a bit later on. And we begin by taking a random integer, any random integer inside 1 and 100, and see that if the modulo value by 2 is 0 or not. Basically, we are checking it is even or not. If we encounter an even random number, then we see that if it is present inside check folder or not, already present inside check folder or not. If it is, then we ignore it, and if it is not present, then we create another file. This is how we create a file in Python. You use the open function, and we signify the name inside it, and we create another file inside it using the same number we encountered. Or else, if it is not an even number, then we create a new folder by the same name. And lastly, we repeat this process for 8 times, checking if the number of files or folders present inside the check directory is 8 or not, and we then come out of the loop. So basically, we are creating a new file using the open function, and we open it in the write mode. By default, it is the read mode, and then we close it. Always remember to close your files. It is a good practice. So never forget to close them. If you are going to create a new file, remember to close them as well. So we create files for even numbers encountered and folders for odd numbers encountered. Now, if you execute it, oh, sorry, I haven't imported random. We already have a check file, I guess. So let us delete that first of all. Yeah. And now, if we go through it, it will take some time, and I guess it is executed. Now if we check inside it, there is a check folder created, and as you can clearly see, these are all the files present here. All the files we encountered, 1, 2, 3, 4, 5, 6, 7, 8, all the files are present here. There are some files, there are some folders, but as you can see, the last 4 files are present and the first 4 are folders. Now how did I know that? I knew that because I could see it in the interface, but how do you know ultimately in Python that whether you've created how many files, how many folders? So if we check it out, these are the files folders created, but from here you cannot know which are files, which are folders, right? So let us create a list named directories and another for files. And for each item present in the list directory of the check folder, we check whether it is a file or not directly using the isFile function. OS module provides that facility as well. You can directly use the isFile function and check whether it is a file or a folder. Now if you execute it and check out the directory folder, you can see, as I already told, the first 4 are folders: 8517, 8517. These are the directories, and the remaining are the files. The last 4 are the files. So you can also check whether you have encountered a file or folder using the S file directory. Now let us remove that as well. Yeah, for copying this directory, you could have used the copy tree directory, but I don't want that. It is basically useless and does not have any useful data, so I'm going to delete that. Now if you delete that, there is no folder as checked now. it is completely removed from our location. So now we came across the function in Python used to create files, right? You can also open existing files using this command, but since there was no one.txt present, we first created that the same command creates it if it is not present. Now by default, if you don't justify this W thing, which stands for write, it opens in the read mode. You cannot write anything into it, you can just read the data out of it. And by default, if you don't specify anything, it opens in the read mode. Now let us take us some random string consisting of many lines, and let us write it into S. We haven't opened that. As I said, we need to open it using in the write mode to be able to write into it. So if we now write it, it returns the number of characters written, and always remember to close that. Now we create another file, namely 2, in the same W mode, and this is another method you could have written inside the file. Instead of opening it separately and writing it again, you could have directly written with open and written the data into it. Now if you check, there is another file named 2.txt and hello world is written inside it. Now nextly, we see how to read data into it. Now since we have opened the file here without using any mode, without justifying any mode, it opens in the read mode by default. And if we now read into it and print the data, you can clearly see what was written inside it. It reflects again. If you see here, these are the lines present here, and if you read and display the data, then these are the data printed. Now suppose you again read the data and now print it. Surprisingly, you don't receive anything. Now why is that? Now when you execute the read command, it basically checks it goes through each character bit by bit, and after reading the entire data, it is present at the end of the file. The cursor, the pointer inside the file is now present at the end of the file, and if we execute the read function again, then there is basically no data it can now read or print. So we always, if you want to read the data again, then you need to use another function, namely seek, and you need to put in 0 inside of that, or the location from where you want to read your data. For example, if you want to see how long is this character line, if we check it out and check it out its value, it's 29. So the first line consists of 29 characters. Now if we read it again and print according to it, now this seek function has moved our pointer to the end of the first line, as a result of which we get all the data present after the first line, which is the second line onwards. You can also find out the current location of the pointer, and it will return the current location. And since it is at the end of the file, we had checked there were 135, and now it is at the end of the file in the next line, so it is 138. Now, as I already said, if you want to move the cursor to the beginning of the file, you can use the seek function and justify 0. Now the cursor is at the beginning of the file, and if you want to print the entire data, you can do that using read function. And the tell function now returns you as 0 since it is at the beginning of the file. Now, there is another thing which I wanted to say. Now, suppose you have a flower file. Let us download a flower image. Yeah, this is the exact location inside the E drive, as I was already speaking of. I'm going to save it inside the folder we are currently working at with the name flower. Now if we check it out, this is the image of flower. So yeah, let us go through that. Let us open that in the read mode first of all. We read it and find out its length. It's quite a lot. This is the data present in the form of bytes and digits. This is how the data is basically stored for an image. And suppose you want to edit your photo somehow, and suppose you want to cut it in half. And surprisingly, you can do that using Python as well. You don't need to use the trim of, tool of your computer. You can do that using Python now. Suppose this is what we are basically doing. We are slicing the data. We have already covered slicing in our previous lectures, and we are cutting it into half. Now, suppose we open another JPG file and we write the half of this data inside that new file, and we close the current file. Now, to display an image in Python, you need to use the IPython module, and inside that the display thing, and we need to import image. Now, suppose you import it and now display the image part. You can see this was some image I was previously working on. Now the flower thing is this. This is the original image and the new image we created, and this is clearly the half of what you can see. This is how you can trim an image into half in Python directly using file handling. You can also perform interesting things like when you can convert it to black and white, you can convert it to 1/4 or use some different colors on it. You can do that all using Python. I would like to explore you more into it and well more into it. It is quite interesting, I guess. So go through it. So we have used the image function inside the IPython module and displayed the images. This is the new image we copied the half of data into, and this is the older image. Now let us check if it is closed or not, and yes, we have closed it here. Yeah. So nextly, let us see what else we can do with file handling in Python. Now, suppose you want to store some important data into a files directly using Python. You worked on it, you have the database of many students, the marks of many students in different subjects. Now you need to copy that into your files folder. How do you do that directly? Let us first open another text file. Suppose we open another text file. Yeah, let us reduce the number of students. It will take a lot of time. Then we open it again in the append mode. Why do we do that? Append mode is something like you get the cursor at the end of the file, at the end of the data which was already present inside the file. But if you open it in the write mode directly, then whatever data you write into it will be overwritten on the existing data. But if you want your existing data intact, then you should open it in the append mode ideally. So if you want to write some fresh data, use the write mode. But if you want to continue writing into your file, always remember to use the append mode. Now, let us input some useful data. Basically, what we are doing is that we are inputting useful information using the input function of Python, and then we are immediately writing it inside the file. And all the time the file is opened, and after the execution of the loop, we are closing the file. So suppose we enter some random names and random marks. Yeah. Now the loops has executed 3 times, and now if we see what is inside of that, you can clearly see the data we inputted now is written inside the percentage folder. If you check it out now, you can clearly see this is the data we have obtained already inside the file folder without doing anything directly. We have simply used Python and we have all the data inside of that now. So this is how you can write into a file directly. Now could have done the same thing instead of using this type thing. You could have opened it, you could have read the data, and you could have printed the data directly. But suppose you use the shell output format and check the format of your data. You can see all these tabs and next line characters we have provided. So suppose we split them all into using the next line character and now display our data. This is what we have obtained in list format. Now, how could you have handled that directly? Like, how could you have printed it in this format instead of using the f.read format? So, more into file handling, more into handling these type of dictionaries and list data. we are going to go through advanced file handling, namely Json and Pickle. We are going to use those two things extensively. Now let us first of all take some initial data. This is basically a dictionary. Suppose consider the data in a bank. We have an account number, a name and a balance, and for a password for logging into the system. Now let us open another file to write into it, namely bank.txt in the write mode, since we are going to write this data, and we close that after that. Now we reopen it in the read mode and read the data inside it, and now we print it. You can clearly see it prints the data in the form of a dictionary. But if you actually check the type of data, it is a string. This entire thing is a string. It is not a dictionary. It looks like a dictionary, but it is a string. So you clearly cannot traverse it like a dictionary. You cannot find the keys, you cannot find the values, since it is a dictionary. Now you could have done that editing thing and stored it into a dictionary by using some deep slicing, splitting, all those things, but it gets very complicated, right? Even to display this information in a particular format, we have done so much of slicing and splitting. So in order to make easier that thing, we basically can use the eval function. Let us begin with that. What is eval? Now, first of all, we open the same file, read the data. Now we use the eval function, and now if we check the type of dictionary, type of the data, we get it as dictionary instead of string. Eval can basically know the type of data stored in. If it is placed inside curly brackets, it will return you as a dictionary. If it would have been inside square brackets, it would have returned you the list instead. Now, suppose let us get us familiar what other things eval can do. Eval is can be directly used to calculate expressions as well. Suppose I enter 4 plus 5 directly. It should have taken it as a string, but instead it takes it as integers. It knows that these are integers and plus is provided as an operand, and it returns the result. But if it would have given some random string, you cannot work on that. What would it do of that? If I provide C code inside it, it will give us an error. Namely, C code is just not defined. What would eval do with that? If you provide some expression, then only eval can do something about it, right? So always remember, eval can be used to know the type of the data we have, or perform some operation into it directly in the string mode. Now, as I was speaking of, we are going to come across two very important concepts in advanced file handling, namely JSON and Pickle. These two are used for object serialization and deserialization in Python. It must be sounding complicated, but once you see its use, it will become very easier to understand. So there are two functions namely associated with JSON and Pickle, both of them, and those are dump and load. So dump is used for serialization and load is used for deserialization. Suppose we have a predefined dictionary as such. Now you can clearly see the type of it is dictionary. Now suppose we use json.dumps and dump it into another variable. Dump is basically used for object serialization. JSON is very handy because Pickle, although performs the same task of object serialization, it is not present in other languages. So this is where JSON comes in handy. Python offers out of the box a JSON encoder and a decoder. To store and load JSON, you can use the dump and load functions respectively. So in order to store JSON data, you use the dump function, and in order to load the same data, you use the load function. And since they are same as in pickling, you can easily remember them as well. So suppose now we dump the data present and we now check it. Yeah, we haven't dumped it. Yeah, sorry. We need to import these, and now if we dump it and check X, it has now been converted into a string. You can clearly see it is not a dictionary, it is enclosed within quotes. And if we check the type of data, it has now been converted into a string. Now suppose we load the same data again and see it now, there are no quotes, right? It has now been converted into a dictionary data again. So what you were doing using eval function can be directly done handily using the JSON thing, and dump will convert it into a string, and load will again recall it as a dictionary. Now suppose we have that file hello.txt, and this is the data we currently have, and we dump the same data inside the file. We dump D inside of F, the dictionary, inside the text file. Nextly, we close the file, and now if we open it in the read mode and print its data, you can clearly see the same data we had, and it is now in the present in the form of string. Now suppose we would have used the load function instead and now checked its type, then it would have given you as a dictionary instead of a string. So whenever you have some data present in the form of dictionary, always remember to use JSON, because JSON basically stores data in the form of string, and when you use them, when you want to operate on them, it will again return you as a dictionary. So it is very useful, which will come in handy later on when you work on projects and development. Now, if we see, this is the data we have obtained, and we can now get familiar with what Pickle does. Now, Pickle is used for serializing and deserializing Python objects, as I've already told. It is a great way to store immediate results while computing things. Pickling and unpickling can be done with the same two functions, as namely dump and load, respectively. The only thing you have to take care is that you now open the mode in the binary mode. Remember, JSON used to store them in the string format directly, so you used to open the file in the usual way. But for dump, you can clearly see the type of data now is in bytes. If you see, it begins with a small b, indicating that all the data is now present in the binary mode. Now, if we load the same data and display it, it has now been restored to its original form in a form of the dictionary. You can check its type and its dictionary. But now if you want to open it again, since it has been stored in the binary mode, you need to use WB, indicating that the file is now a binary data format, and you cannot simply use the W mode to open it. Now if we dump it again, we dump the dictionary D inside the file and close it, and now open it in the read mode. For read mode as well, you need to use the byte format, and if we check the type of data, it is now bytes. You cannot get hold of what it is exactly, since it is present in binary format. And if we load it and check it again restores to dictionary. So basically, JSON and Pickle do the same thing of serializing and deserializing Python objects, but JSON converts it into string format, and it is available in all languages, so you can use them handily. But Pickle converts it into byte format, and it is only available with Python. So be careful when using them. So I guess this is enough. This sums it of file handling easily. It is an easy concept, and if you practice it, you will get a strong grasp of what it is, and it will come in handy later on. There is extensive use of file handling when you develop projects. So get used to that and go through it. And if you have any doubts, then feel free to ask to me. Thank you.